Good morning, children. Today we are moving on to the problems based on basic proportionality theorem, which has been discussed already. Now, basic proportionality theorem, it states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, that is here there is a triangle ABC. I will name it as ABC, A, B, and C, and a line is drawn parallel. I am drawing a line EF parallel to BC. So I am drawing a line EF parallel to BC. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, that is the points are E and F, distinct points, the other two sides are divided in the same ratio. So what we are saying is, if this line, if EF is parallel to BC in this triangle, then AE, that is, we are taking only this side, AE by BE is equal to, then you take the ratio of the other side, AF by FC. When you take, you see that the upper part should be together, AE. AE is on the top, then on the other side also, the top portion, that is AF, should be above the line, okay? It should be the numerator. Then EB and FC should be the denominator, or else you can write it as ulta. You can write BE by AE should be equal to FC by AF. You can write it both the ways. Okay, this is what is basic proportionality theorem, BPT. The two sides are divided in the same ratio. Now there is converse of this. Okay, this proof of BPT, basic proportionality theorem, proof is very must. It will be asked. Actually, every year they were learning BPT, it's converse, Pythagoras theorem, it's converse and all. But this year you have only BPT and Pythagoras theorem direct. So these two questions will be a sure shot question for you. So learn the proof of BPT properly. Now the converse of BPT, here it is given, if a line is drawn parallel, then this is, the ratio will be equal. In other ways, converse is, if AE by BE, that is, if we find that the sides are in proportion, if we find that the sides are in proportion, if somehow we are able to show that the sides are in proportion, then we can say that EF is parallel to BC. That is the converse. This is also true. Okay, so while solving the problems, we'll be using, sometimes we'll be using basic proportionality theorem or BPT directly, or we'll be using the converse. Now in 9th standard, you remember midpoint theorem. You have learned about midpoint theorem, children. So how do you do this midpoint theorem? That is, given a triangle, if its midpoints are joined, if the midpoints of the sides or two sides are joined, then the line is parallel to the third side. This you have learned. Now how are you going to prove it using basic proportionality theorem? Now if E and F are midpoint, that is, I am talking about midpoint theorem that you have learned in 9th standard. We have learned midpoint theorem in 9th standard, and then we have done the activity also of cutting and all those things, midpoint theorem. That is, it states that if E and F are midpoints of the sides AB and AC, then when you join these two midpoints, this line EF has to be parallel to the third side, that is BC. EF has to be parallel to BC. How are you going to show that? Now given AE is the midpoint, so E is midpoint, then if E is midpoint, what do you get? AE is equal to EB. AE is equal to EB and AF is equal to FC. So what you get? AE equal to EB means AE by EB is equal to 1 and AF by FC is equal to 1. That is, AE by EB is equal to AF by FC. Now can you see? That is converse. If AE by BE is equal to AF by FC, then therefore EF is parallel to BC. That is by converse of BPT. by converse of BPT. That is, if these two sides are in proportion, then the lines are parallel. Now there is converse of midpoint theorem. Converse of midpoint theorem is there. What is the converse of midpoint theorem say? That is, if a line is parallel, a line joining the midpoint of one side and parallel to the third side. So E is the midpoint, E is given as the midpoint and it is parallel to, EF is parallel to BC. Then F should be the midpoint of AC. Then F should be the midpoint of AC. That is the converse. How are you going to prove that? That again you can take, if E is the midpoint, AE by EB is equal. Converse of midpoint. You should remember this converse of midpoint. Converse of midpoint says that a line joining the midpoint of one side of a triangle and parallel to the third side will bisect the other side. That means F will be the midpoint. If E is the midpoint and a line is drawn parallel to BC through E, then that line will bisect AC. That means F will be the midpoint. How are we going to show that E is the midpoint? So similarly as we showed above, if E is the midpoint, AE by BE will be equal to 1. Isn't it? And then you have EF is parallel to BC. If EF is parallel to BC in the triangle, then AE by EB or AE by BE should be equal to AF by FC. Why? That is BPT, basic proportionality theorem. If it is parallel, then the sides are proportional. But AE by BE is equal to 1. Therefore, AF by FC is also equal to 1. Or you get AF equal to FC. AF is equal to FC means F is the midpoint. Okay. So, these midpoint theorem questions are there in your worked out in your questions, example questions for you to solve. So, I've just explained it over here. You can go through your textbook. There are questions there and then you can solve it accordingly. Okay. Now, let us move on to the questions here. So, basic proportionality or converse of basic proportionality, I said it is directly the proportion that you have to see. So, here the question is given first and second. DE is parallel to BC. In both the cases, this line DE is parallel to BC. Now find EC in first one. You have to find EC. This is the question. EC in the first one and AD in the second one. You have to find AD in the second one. Now how are you going to find? We know if ED is parallel or DE is parallel to BC, then the sides, that is this and this, AD by DB should be equal to the other two sides, that is AE by EC. So what is AE? You can just substitute. AD is 1.5, DB is 3, that is equal to AE is 1 and EC we don't know. So how do you do it? Cross multiply. When you cross multiply, you will get EC is equal to 1 into 3 by 1.5. Now, how will you get it? That is 3 divided by 1.5. What is the answer? 3 divided by 1.5. What will be the answer? Find it out. That is equal to 2. So, you get here EC is equal to 2 centimeter. It is very easy. So, these type of questions will come for MCQs. The second question, if you see, the second one, it is given the same way by using BPT. This is by using BPT, we are writing this. By using BPT, we can write here AD by BD is equal to AE by EC. This is again by basic proportionality theorem. Why? Because it is given that DE is parallel to BC. These two are parallel. When these two are parallel, then the sides are proportion. So AD we don't know. We write it as AD by BD. We get it as 7.2. That is equal to AE is 1.8 by 5.4. Now how do we get AD? AD is equal to, we'll get it as 1.8 into 7.2 by 5.4. Now we have to find the answer. The answer is going to be 1.8, 1.8. This 1.8 by this is 5.4, that is equal to 1 by 3 because 3 times it will go. So here you have 3 here, 3 in 7.2, you'll get it as 2.4. So the answer will be 2.4 centimeter. Okay, so similar questions you can expect in your MCQ questions. Now let us move on to the next question. E and F are points on sides PQ and PR respectively of triangle PQR. So we have to make a triangle PQR. I'm going to make the triangle PQ and R. Now what is given? E and F are points on the sides PQ and PR respectively. Respectively means each one for the same. So E for PQ. PQ side it is E. And F for PR. So this point is F. E and F are side points on the sides PQ and PR. For each of the following cases, state whether EF is parallel to QR. So you are getting this EF. These are 2 points and then we are joining these 2 points and then we are getting EF. Now we have to find whether EF is parallel to QR or not. In the first case it is given, let us take the first case. In the first case it is given PE equal to 3.9. PE is 3.9 and EQ is 3. PF is 3.6 and FR is 2.4. Now you have to find out whether EF is parallel or not. If EF is parallel to QR, then you know that PE by EQ should be equal to PF by FR by BPT. Okay, so what is PE? 3.9 by EQ is 3 should be equal to 3.6 by 2.4. This is what we have to show. But before, we cannot directly write like this. If it is parallel, then it should be equal. Now we can find PE by EQ first. We'll first find PE by EQ. So I am writing here PE by EQ is equal to 3.9 by 3. What is that? That is equal to 1.3. Now if I find PF by FR, PF by FR is equal to 3.6 by 2.4. So is it equal to 1.3? It is not equal to 1.3 or it is not equal to PE by EQ. So these two ratios are not equal. Then what can you say? Therefore, EF is not parallel to QR. EF is not parallel to QR. Now let us consider the second condition. The second question we have here is PE is equal to 4. So we'll erase these marks. PE is given as 4 and let us write those values what they have given to us. So PE is given 4, QE is 4.5, PF is 8 and RF is 9. So what we do is, in the second question, we'll first find PE by EQ. PE by EQ is equal to 4 by 4.5. And we'll find PF by FR. PF by FR is equal to 8 by 9. You can, if you divide by 2, these two if you divide by 2, then you will get, by looking at the numbers, we'll know what we have to do. 4 and this is 4.5. So you say 4 and 4.5, these two are equal. So PE by EQ is equal to PF by FR. So if they are equal, then you can say that EF is parallel to QR. Why? By converse of BPD. If the sides are proportional, then the lines are parallel. Converse of BPD. Okay, so this what I have done here 4.5. Uh, this is because I know the numbers, so I've done it very easily, 4.5 and all those things. But if you are not very comfortable with the numbers, children, you can multiply and you can find out. That will be wasting a lot of time. You will have to multiply 9 into 4 and 8 into 4.5, and all those things will be multiplying, and you can find that they are equal. Okay, whichever way you want, you have to just show that PE by EQ is equal to PF by FR, or PE by EQ is not equal to PF by FR. Now there is third question, one more question in your textbook. I am doing only two, and the third one I am leaving it for you to solve it on your own. Now children, before we do this problem, I want to tell you one more thing here. That is, whenever we take a triangle as per BPT, this is ABC, the triangle is ABC. Then I told you, if we are drawing DE here, parallel to BC, DE parallel to BC, then I told you AD by DB is equal to AE by EC. There is one more thing, children. AD, if this is of 1:3, you see that this is 1 by 3, then this also has to be 1 by 3. Then if I add AD to this becomes 1 by 4. AD plus DB, that is AB. AD plus DB, that is AB. So instead of taking this AD by DB, we can also consider it as AD by AB. That is considering this triangle, whole big triangle and the small triangle. The whole big triangle ABC and the small triangle ADE. These both triangles are similar. These are the triangles. We are talking about triangles. The down part is a trapezium, but the upper portion is a triangle. So we have ADE. So ADE and ABC are similar. So what you get is AD by AB. You can take these sides. AD is the side of one triangle and AB is the side of the other triangle. So AD by AB should be equal to AE by AC. That is also part of basic proportionality theorem, because the sides of the triangles are in proportion. So here we have two other triangles, that is a small triangle ADE and the big triangle ABC. So when you consider that way, then you get AD by AB equal to AE by AC. So this is what we are going to use over here in this question. Okay, so let us consider the first one. It is given LM is parallel to CB. So if LM is parallel to CB, let us mark the LM here. And I am going to take that triangle separately. So I have the LM here, and we are talking about the triangle ABC. We are talking about the triangle ABC. Now let us see, children. I am drawing that triangle here, A, B, C. I am drawing the triangle here. This is my A, this is B, and this is C, the triangle. And then I have a line LM parallel. Now this is my small triangle ALM, and then I have the big triangle, that is ABC. There are two triangles. Sides of the triangles should be proportional. Now if I take that way, if LM is parallel in triangle ABC, LM is parallel to BC. Then considering these two triangles, small triangle and the big triangle, why I am considering this way, it is given as AM by AB. AB, when you say, it is a long side. Can you see? AB. It is not MB. Usually we take the smaller side. It is not MB given here. It is the big triangle. The whole thing is given here. That is why I am taking the whole triangle as such. Okay. So triangle ABC and LM is parallel to BC. Now using BPT, what can we say? AM is of the small triangle. AM by AB should be equal to. Now we have to see the other side. Other smaller side of the triangle is AL, by the long side is AC. Okay, this is by basic proportionality theorem. If the lines are parallel, then that is our first equation. Now let us take the next triangle, the other triangle, that is the downward triangle. You have A, D and C. So here we have A, D and C, and you have the line L, N. Can you see? This down part, this triangle is what I am taking. Now I have the small triangle here ALN and the big triangle, that is ALAC D, the big triangle. I'm going to consider these two triangles, the big triangle and the small triangle. Now if I consider those two triangles, then in triangle ACD, given LN is parallel to DC. If these are parallel, then the sides we can write AN by AD. We are taking the two big triangle and the small triangle. AN by AD will be equal to AL of the small triangle, and for the big triangle the side is AC. AL by AC. That is my second one by BPT. Now look at the first and second equation. The right hand side AL by AC, AL by AC. So from 1 and 2, right hand sides are equal. What about the left hand sides? If the right hand sides are equal, left hand sides also should be equal. So what do we get? AM by AB is equal to AN by AD. So this is what they have asked us to prove. Show that AM by AB equal to AN by AD. We have proved it. It is very simple. But the thing is, we are taking the small triangle and big triangle this time instead of the sides, instead of the small portions. Okay, we are taking the two complete triangles. So that you have to be clear about. Now in the next question, see here, DE is parallel. Now we have to draw the triangle again. DE is parallel to AC. So let us see DE. DE is parallel to AC. Now let us take these two triangles. So I am taking the triangle starting from B to A to C. So I am taking this triangle. B is here, A is here, C is here. And then I have D, E. Okay. So now how am I going to do this is the question. So I have DE here. Now when I write, how will I get? See the sides. It is given BE and EC. BE is smaller side, EC is smaller side. So we don't have to take the whole triangle, we'll take the sides. Now if in triangle, which is the triangle I have taken in triangle ABC, in triangle ABC, given DE is parallel to AC. If DE is parallel to AC, then by BPT what can you say? It's the smaller sides that they've given. So we can write BD by AD is equal to BE by EC. That is the first one by BPT. Now the second one, they have given DF is parallel to EE. DF is this and AE is this. So we are going to draw the next triangle. That is, we have the triangle here. B is starting here, A is there, E is there. And then we have DF. So here it is given DF is parallel to AE. DF is parallel to AE. So in triangle, second one is in triangle BAE, what is given? DF is parallel to AE. If DF is parallel to AE, then how can we write BD by AD? BD, that is this portion I am taking, BD, and this is AD. BD, DA or AD, anyway you can write. BD by AD is equal to, the other side I'll get BF by FE. BF by FE. This is my second one, that is also due to basic proportionality theorem. Now look at first and second. BD by AD on the left hand side. BD by AD on the left hand side. From 1 and 2, both LHS left hand sides are equal. So what about right hand sides? Right hand sides should be equal. So what do we get? BF by FE. Left hand side is BF by FE. That is equal to the other right hand side. Right hand side here in the second equation, right hand side is BF by FE. In the first equation, right hand side is BE by EC. Can you see, children, these formulas, this finding out is very easy. Clearly you can just write down directly. Anyone can write it directly. You have to just understand that which one you have to take as which triangle you have to take. Then you have to understand the BPT, which is parallel, and which two triangles you will be considering. These things, if it gets clear in your mind, then you can easily do this. Next, let us see. Here, DE is parallel to OQ. DE is given. DE is parallel to OQ. Now we'll take the triangle where these two are parallel. Which is the triangle we are getting? I'll just draw it here. I'm getting the triangle P, O and Q. And DE is parallel to OQ. DE is parallel to OQ. Now from this what can I write? In triangle, my triangle is triangle POQ. In triangle POQ, they have given DE is parallel to OQ. Now if I write basic proportionality theorem, what will I get? PE by EQ is equal to PD by DO. That is first equation by BPT. Now what is the second one? We have done DE by OQ, we have done. Next one is DF is parallel to OR. DF, this is the one. DF is parallel to OR. So this line and this line we have to take. Now what is that triangle? If I take the triangle, I have POR. I am drawing it like this. P is here, O is here and R is here. And then I have the line here DF. Now if I get this, which is the triangle I am taking? In triangle POR, given DF is parallel to OR. That is given in the question. DF is parallel to OR. If DF is parallel to OR, then what can you write? Then you can write PD by DO is equal to PF by FR. That is the second equation by BPT. It is so simple by BPT. Now you see the first equation and second equation. From 1 and 2, what do you get? From 1 and 2, what do you get? PD and DO is here. PD and DO is here. Both the sides. So what can you say about the other two sides? From 1 and 2 we get PE by EQ is equal to PF by FR. Now look at the figure given. Okay. Now is where you have to look at the figure that is given. Let us see. Dark color, which one will take? Let me take violet. Okay. Now see here. PE by EQ. Where is PE? This is the one. PE by EQ. We have got it as equal to PF by FR. PF by FR. Now what is that triangle you see? That is the big triangle here. That is PQR. Now the point here is PE by EQ is equal to PF by FR. So what is this line? This is EF. That is, this line is EF. The big triangle, this big triangle we have taken, and then we have EF. Now in this case, what do you say? They have written PE by EQ is equal to PF by FR. PE by EQ equal to PF by FR. Then what can you say about EF? Then EF is parallel to QR. Why? If the sides are proportional, then the line is parallel. The reason is converse of BPT. If the line is parallel, then the sides are in proportion. Opposite is, if the sides are in proportion, then the lines are parallel. So by converse of BPT, EF is parallel to QR. You just remember this. If you have to show that sides are in proportion, then you write BPT. If you have to show that two lines are parallel, then it is converse of BPT. The question is ABCD is a trapezium. So let me just make the trapezium and I am going to mark it as ABCD. A, B, C, D. You know that naming it should be clockwise or anti-clockwise. So I have A, B, C, D, the trapezium, and there are its diagonals. There is already one diagonal there, BD. Then the other diagonal is AC. The diagonals meet at the point O. Now you have to show that AO by BO is equal to CO by DO. This question is important, children. The two questions are there of trapezium. These two questions are very, very important. So see here, what I'm going to do is, given AB is parallel to DC, that is given. These two lines are parallel. Now I'm going to draw EO, or you can write it as construct, draw EO parallel to AB. So I am drawing EO parallel to AB. Now if I consider EO parallel to AB, then what do I have? EO is parallel to AB. If I draw, then EO is parallel to DC also. Why? Because it is already given AB is parallel to DC. Now what am I going to do? Now let us consider this triangle. I've just made one construction of E here. Now I'm going to consider the triangle. First let me consider the triangle ADC. In triangle ADC, AB not ABC, it is ADC. In triangle ADC, that is this triangle ADC. This is the triangle I'm talking about. If I'm taking this triangle ADC, now what do I have? EO is parallel to DC. EO is parallel to DC. So what do I have? I can write AE by ED is equal to AO by OC. That is BPT. That is my first equation, BPT. Now I am taking the triangle, ulta triangle. In triangle ABD, that is I am taking this triangle, children, ABD. I am taking this triangle ABD. That is, if I take A, B, D, this is A, B, D. If you are not clear, then you can draw the triangle like this and then you can find out. Then there is EO here. Now in this case, what can I write? AE by ED is equal to BO by DO. Isn't it? That is also by BPT. That is my second equation. Now you see the two equations, AE by ED. AE by ED, AE by ED. Right hand sides are equal. So what about the left hand side? That is AO by OC. AO by OC is equal to BO by DO. Is that what we have to find? No. We have to find BO down. AO by BO. BO should be down. But here BO is above. OC should be up. Can you see? What do we do? Just cross multiply. When you cross multiply, you will get AO by BO is equal to OC by DO. OC or CO, it is the same. Whether you write it as OC or you write it as DO or CO, it is the same. So we have got AO by BO equal to OC by DO. In this trapezium, you have to just remember that we have to make a parallel line. We have to construct a line parallel. Why are we making this line parallel? Because for these two, both the triangles what we are taking, that is this big triangle that we are taking as well as the small triangle we are taking, because the things that are coming under, we need one common side. We are taking the common side as AD. AE by ED is our common side. Then the other sides we are getting it. Okay. So that way we are making a construction and then doing it. Then there is one more, the last question for you. The diagonals of a quadrilateral ABCD intersect each other at point O. The same question. ABCD, there is a trapezium A, B, C and D, and the diagonals they meet at O. The diagonals they are meeting at O such that AO by BO equal to CO by DO. Show that ABCD is a trapezium. Now how are you going to show this, children? Now we have to show that this is a trapezium. ABCD is a trapezium. Now for showing that ABCD is a trapezium, we know that for trapezium in a quadrilateral, one pair of opposite sides has to be parallel. So we have to just show that one pair of opposite side is parallel. So what are we going to show? We have to show that AB is parallel. The question is to show that AB is parallel to CD. So if we show AB is parallel to CD, then we can say that it is a trapezium. Now how are we going to show? We don't have anything here, no parallel lines, nothing to show using BPT. So what we are going to do? Construct. I am going to construct AF parallel to, sorry, not AF, I am going to construct EF parallel to AB. So I'll construct here. Here I am constructing EF that is parallel to AB. Okay, EF is parallel to AB. Now what do I get? If I draw EF is parallel to AB, what will I get? In triangle ABD, triangle ABD, this is the triangle that I am taking, ABD, this triangle. In this triangle, there is this EO is there. Okay, so if I take this triangle, if I draw it like this, then you will understand. There is AB, there is D, and then there is E, and here you have O, and E is parallel to AB. So what do you get in triangle ABD? What do you get? AE by ED is equal to OB by OD or BO by DO. Anyway, AE by ED is equal to BO by OD. Okay. Now, see here children. This is my first equation. This is by BPT. Now, what is given to us? It is given that AO by BO is equal to CO by DO. This is given. Now, from what is given, what can you write? You can cross multiply like what we did in the earlier this thing. We'll get AO by CO is equal to BO by DO. Okay, so this is the second equation from which. Now you see the first equation and second equation, BO by DO is on the right, BO by DO is on the right. So from this what you get? You get the left hand sides are equal. From 1 and 2 you get AE by, from 1 and 2 you get AE by ED is equal to, what do you get? AO by CO. So see here the triangle AE by ED is equal to AO by CO. AO is this side. AO by CO is this side. So what is the triangle that we are getting? We have these two sides, AE by DE. So the triangle that we are getting is like this. It is coming like this, children. A, D, C. And there is E, O. So what do you get? Now what you get? AE by ED is equal to AO by CO you got. So from this what will you get? EO is parallel to DC by converse of BPT. By converse of BPT. That is, if the sides are proportional, then the lines are parallel. So EO is parallel to DC. But what have I considered? We have constructed EF parallel to AB. Now we are seeing that EF is parallel to DC. Or you can, instead of EO, you can write as EF also. Okay, EF is parallel to DC. Now from this what you get? EF is parallel to AB and EF is parallel to DC. So from this what you get? That is AB is parallel to DC. Because this line EF we have constructed parallel to AB. When we drew it parallel to AB. But when we are doing the BPT, we are getting that this EF is parallel to DC. EF is parallel to DC. EO is parallel to DC means it is same as EF is parallel to DC. So when three lines are like this, that means when one line is parallel to another, you'll get it. That is AB is parallel to EF and EF is parallel to DC. Therefore, what do you get? Therefore, AB is parallel to DC. That is what we are supposed to prove. AB is parallel to CD. So we have proved using converse of BPT. And with this, we come to the stop of this first exercise using BPT, basic proportionality theorem, and converse of basic proportionality theorem. So what we'll do today is You'll watch this and then you'll write all this in your notebook. Okay, student? Bye-bye.